Welcome to this Fidelity Pointwise tutorial where we're going to show you how you can very quickly create a surface grid. I have in front of you the Fidelity Pointwise GUI where I have already imported the geometry that we're going to be working with in this video. As you can see, is half of a quadcopter. The first thing that you need to do is to actually understand what you have in this geometry and to basically prepare this geometry for mesh generation. And what do I mean by that? I'm going to come here in the list panel to the database option and I'm going to expand. I can see right there that right off the bat I have 3 database models that are actually physically connecting. The first thing that you need to do to prepare this geometry for meshing is to ensure that you assemble all your database models into a single watertight database model. So we're going to do that as a first step. The first thing that I like to do is to select my models. And right here on my toolbar, I'm going to select the shaded option so you can see a little bit better what's going on. As you can see, these 3 models, so the entire geometry is going to be shaded, and I have a better view of my geometry. The geometry by default is going to be rendered in that pinkish color that Fidelity Pointwise uses. The next thing, with my 3 models still selected, to better visualize what is going on, I like to use this option right here, which is the rainbow colors. If I click on that one, you can see that every single model is going to be rendered in a unique color, and you can see very clearly what you have in your geometry. So once we understand what's going on as it comes to database models, I'm going to reselect my 3 models in this case, and I'm going to assemble them into a single watertight model. Watertight means that I'm not going to have interior gaps in my model. Doing this is going to ensure that when I actually create my surface grid on this geometry, that surface grid is going to have a point-to-point connection everywhere, and it's not going to have interior gaps, which of course you are not going to want. So with my 3 models selected, I'm going to go to Create, Assemble Models. As you can see, the Assemble Models tool opens up, and you have first thing right here on the top, a table that is going to show you how many models and quilts you have currently selected, but it's also going to show you the kind of boundaries that you have. Lamina boundaries are rendered in red, and those are the boundaries that are going to indicate that you may have an interior gap in your geometry. Those are the ones that you have to pay special attention to. Pointwise is also going to show you in that nice light blue or cyan color the manifold boundaries that indicate that boundaries are properly connected. You also have in here the tolerance frame. In my particular case, I'm going to use the default tolerance of 1e to the minus 3 that is actually set up based on the overall size of my geometry. That is going to work fine in my particular case. However, if you actually assemble your database models and you see that you have some interior gaps, one of the things that you can do is to uncheck the use defaults option right here and increase the tolerance a little bit in hopes that that is going to take care of those interior gaps. In my case, the default value is going to work fine, and I'm going to then click Assemble to let Fidelity Pointwise start assembling my models. What you're going to see is that the rendering of my models is going to change. It's going to be rendered in a nice green color that is going to allow you to see what is going on. Pointwise is also going to render in red and cyan the different boundaries that you have in your geometry. And as I mentioned, you have to make sure that you don't have any red boundaries in the interior of your geometry. So I'm going to do a quick inspection of my geometry, and I can see that everything is nice and cyan. All the boundaries have been assembled properly. Of course, you're going to have in the symmetry region 10 lamina boundaries that are going to be rendered in red, and that is expected because this is, of course, an open geometry. Once I am sure that I don't have any interior gaps, I'm going to simply click OK, and I'm going to let Pointwise wrap up the assembly of my database models. At the end of this process, I should have a single watertight database model. My models have been assembled right now, and as we can see in the list panel, now I have a single watertight database model that doesn't have interior gaps. The next thing that I want to do is to ensure that my quilts have been assembled properly. So what I'm going to do is select all my quilts right there, and I'm going to use the same tool, the rainbow colors, to basically render each one of those quilts in a unique color so I can see what is going on. This particular geometry has been pretty much all quilted except the central part of my quadcopter. So let's take a look at one of the interesting sections, which is the blade, one of those blades that I have in here. And as you can see in here, this is how we recommend actually quilting a blade of this type. You can see that the blade has an upper surface, a lower surface, a blunt tip, and it also has a blunt trailing edge. So in this case, we do not recommend wrapping everything, the entire blade, with a single quilt. That is not going to give you the kind of surface mesh that you're looking for. We do recommend quilting these this way. As you can see, we have one quilt for the upper surface, we have one quilt for the lower surface, a separate quilt for the blunt tip, and last but not least, we have a separate quilt right there for the blunt trailing edge. And again, this is how we recommend quilting these type of blades. In this particular case, the only thing I have to do is to select all these quilts right here, and I want to assemble all those quilts selected on the central portion of my quadcopter into a single quilt. Why do I want to do that? Keep in mind that the quilts define meshing regions, which means that each and every one of those quilts is going to receive a single domain. So I'm going to select all my quilts that I would like to assemble all together. Of course, when assembling quilts, you need to make sure that those quilts belong to the same database model, which is the case here since we assemble everything into a single model. So after the quilts have been selected, I have a tool right here on my toolbar that is the Assemble Quilts. I can simply click on that one, and very quickly Pointwise is going to assemble all those quilts into one, as you can see right there. At this point, my geometry is ready to be meshed. The next thing that I'm going to do is to select my model, and to start the creation of the surface grid, I'm going to go to Create, Automatic Surface Mesh. The Automatic Surface Mesh tool is going to open up, and this tool is going to allow you to very quickly and with minimal input from you, the user, create a very nice surface grid on your geometry. Keep in mind that in this video, we're not going to discuss every single tool or option that you have in the Automatic Surface Mesh functionality. If you want more details of each one of these particular options, I recommend that you review the Fidelity Pointwise user manual, where we have nice descriptions of every tool. So as you can see in the Automatic Surface Mesh tool, you have three tabs: the Global, Surfaces, and Boundaries. In the Global tab, you have several sections. First, you have the Geometry Characteristics section that allow you to actually get a better understanding of the different sizes involved in your geometry, like the max model extents, the minimal boundary length. You check this box right here and put your mouse pointer right here where the number is. It's going to zoom to whatever that minimal or smallest edge is located. If you actually move the pointer away, it's going to zoom back to where you were. That's a pretty nice feature to have. This tool, or this section right here, is also going to show you the model boundaries that you have. Those are those red boundaries that you might have if you have gaps in your geometry. We also have in here the symmetry boundaries. If I click on that particular checkbox over here, you can see that the symmetry boundary that we have in our geometry is rendered in green. So Fidelity Pointwise is recognizing that symmetry and is rendering that in green for you to see. The next section right here is the resolution section, where you actually define the resolution of your surface grid. Basically, this tool right here, the first one, is going to allow you to define what the smallest target edge length in your surface grid is going to be. This one right here is going to allow you to define what the largest target edge length in your surface grid is going to be. You can also define the curvature resolution. That is going to give you an idea of how refined you want the curved sections of your geometry to be meshed. The smallest that number in here in degrees, the more refined those curved sections are going to be. You also have a section right here that is going to allow you to define the goals that you want for your geometry. For example, what kind of aspect ratios? What is the maximum aspect ratio that you want to allow on your anisotropic cells? The default value is 10. For this particular case, we're going to define a maximum aspect ratio of 30. You also have a boundary growth rate of 1.2 set by default. Last but not least, you have in here the algorithm. We're going to use advanced in front, which is going to give us all triangular cells on the surface grid. You also have quad dominant and hybrid options. The last thing that you have in here is the display section, where as you can see, you have several metrics going on. In particular, you have three: the area ratio, aspect ratio, and the max angle. For each one of these metrics, you have a threshold in there, which is based on our best practices. And if after you create your surface grid, any of those cells on the surface grid actually violate these metrics based on these thresholds, that information will be displayed right here in this section. In the display section, you have also two more options. One is going to be this one, the show surface curvature. If you click on it, it's going to render the different curvature that you have on your geometry, and is going to present this nice color bar right here on the left with the radius of curvature. If you zoom in, you can see right here that Fidelity Pointwise is going to show you the different curvature that you have in different areas of your geometry. So I'm going to hide this. And the next thing that I want to show you right here is that you also have a sized field option, show size field. If you actually click that button, it's going to render the different size field that you have on different parts of your geometry based on the current settings that you have for this tool. So I'm going to go ahead and click on the show size field and see what we get. All right, the size field has been computed. Keep in mind that this operation might take a few minutes depending on the complexity of your geometry and also the kind of machine that you're using. So let's take a look at what we have in here. First off, you can see that you have on the left the target edge length. Everything is grayscale, and you have a nice toolbar showing you what is going on. You can also see, if I zoom a little bit closer, that where the mouse pointer is, you have a little cell that is going to give you two pieces of information. First, it's going to show you the kind of cell that you're going to get in that area. In this case, it's going to be a triangular surface cell, but it's also going to show you the target edge length for the cells in that particular area of your geometry. As you can see on the scale on the left, that particular cell is going to have a target edge length of 7.1 in this particular region. If I go to areas of the geometry where more physics is going to happen, you can actually see that the size of your cell is going to be smaller. You can also see that the size of that cell is going to get smaller and larger depending on where you are in your geometry. So this tool is very useful to kind of understand what your surface grid is going to look like, at least in the sense of the target edge length, before you actually generate the surface grid. So I'm going to hide my size field. Next in line is going to be the Surfaces tab, and as you can see right here, we have two sections. One is going to be the resolution, and another one is going to be the mapping section. For the resolution section, you can create a new filter using the new button right there, and you can add different parts of your geometry to it by selecting the surfaces, for example, and clicking on the set checkbox right here, and you can set a target maximum edge length for different parts of your geometry if you choose to do so. In our particular case, we are not going to use any resolution filter. We are, however, going to use mapping filters. So what are the mapping filters? Let's get a little bit closer right here and take a look at the blunt trailing edge. The blunt trailing edge, as you can see, is a long and skinny surface, like so. And for most CFD computations, it is usually desired to have in these kind of long and skinny surfaces a structure-like grid. And it is also useful to be able to specify how many cells you have across the trailing edge. This kind of behavior you can actually accomplish with a mapping filter. So what we're going to do is we're going to click the new button to create a new mapping filter. I'm going to set an appropriate name for it since I'm going to be assigning trailing edges to this particular filter. I'm going to set an appropriate name. The next thing that I have right here is the type of this mapping filter. You can see the different options in the user manual. You have the automatic, non-force, and thin surface interpolation. In our case, we're going to use the force type right there. And what this type is going to do is force a certain number of cells across the trailing edge. What I'm going to do next is specify how many subdivisions I do want across the trailing edge. In this particular case, we're going to use 5 subdivisions across, which means that I'm going to have 6 grid points across each one of those blunt trailing edges. The next thing that you need to do is to actually assign surfaces to the particular filter that you have defined. As you can see, right now this filter has been defined, but it has 0 surfaces assigned to it. So one of the ways in which you can actually assign surfaces to a filter is to simply come here, select the appropriate surface, and then click on the set checkbox right there. A couple of things that you can see. First off, now we have the number 1 in there because a surface has been assigned to this filter, and you can also see that things are color coded. This is green right here, and the boundary of the surface is now green to indicate that it has been assigned to that particular mapping filter. Now, what happens if you want to assign a large number of surfaces to a given filter? Obviously, clicking or selecting a bunch of surfaces can take a long time. This is when the pattern actually comes into play. If all those surfaces that you want to assign to this mapping filter have been named using a given pattern, you can actually specify this pattern right here to capture all those surfaces at once. In my particular case, all the trailing edge surfaces have been named with the pattern TE. So they all have some name, but in the middle of that name, they have the letters TE. So using regular expressions, I can enter that pattern here. Hit enter, and you can actually see immediately that a couple of things happen. First, all those blunt trailing edges, all those surfaces have been captured and automatically assigned to my mapping filter. And following the little color pattern that you have in here, you can see in my geometry that now all those blunt trailing edge surfaces are rendered in green. So at this point, my mapping filter is ready to go. Next in line are going to be the boundaries tab. In the boundaries tab, you can actually see that we have different stretching boundary. There are 4 boundaries that are defined by default by Fidelity Pointwise, and those are the unspecified, curvature, convex, on concave. What Fidelity Pointwise is going to do is going to try to look at every single edge in your geometry and determine whether it's a curvature edge, convex edge, or a concave edge, and it's going to assign those edges to the appropriate stretching conditions. So you can see things are going to be color coded just like you saw before in other cases. You can, of course, create your own stretching condition and select some particular edge that you might be interested in and assign it to that particular new condition. And then, of course, you can select that condition, come here and change its type. In our particular case, we are not going to do that. We're just going to simply use what Pointwise has already defined for us. Now, keep in mind that the stretching filters are the ones that Fidelity Pointwise uses to determine off of which edges anisotropic cells will be created. In our case, we do not want anisotropic cells grown off of the convex edges that are rendered in your geometry in that purple color. So what we're going to do is select the particular stretching condition we're talking about and come here and change its type to off. After that has been done, I'm going to go to the Global tab, and I am ready to create my surface grid. So click on the Create Surface Mesh button right there. All right, my surface grid has been created. Again, keep in mind that how long this process takes. It might actually take several minutes depending on the complexity of your geometry and the kind of machine that you're actually using to create the surface grid. In my case, you can see right here, this operation has taken almost 2 minutes to create. So let's see what we have. You can see right here that, of course, in areas of less interest where less physics is going on, my grid is going to be a little bit coarser and is going to be more refined in areas of higher curvature and areas of more interest, like, for example, the blades. Now, if I zoom in close here, you can see a couple of things. First, I can see right here that that structure-like behavior that I was looking for the blunt trailing edge, that is what I got right here. I have 6 grid points across, 5 subdivisions across. That is exactly what I was looking for. You can also see these little cells are actually rendered here in red, and that actually is coming from the display section right here. As I mentioned before, we have different metrics, and it also have the number of cells that actually violate those particular metrics according to whatever the thresholds you have defined. In this case, we can actually see that the area ratio has been violated by almost 6,500 cells. The maximum value that we have is about 25. If I actually click on the little show checkbox over here, basically these cells are going to be rendered in red so you can see where they are. Also, if I come right here and I right click on it, you can see you have several options to actually locate those cells a little bit better. So what is going on in this particular case? If I zoom in a little bit closer, it is expected that the area ratio is going to be a little bit higher because you have those highly anisotropic surface cells right here on the blunt trailing edge that are right next to perfectly isotropic cells. So you're going to have that area ratio that is a little bit larger than we would like it to be. So how can we actually resolve this issue? You can see that this goes all along the trailing edges of the surface grid. So the way to actually resolve these is I can go to the Surfaces tab. And if you remember, we actually define a mapping filter where we actually put all the surfaces of the trailing edges. And one of the options that we have in here is the adjacent boundary type. And I'm going to change these from automatic to adjacent grid. What that is going to do is every single surface grid that is basically adjacent to the blunt trailing edges, they're going to grow anisotropic cells to nicely match what is happening in the blunt trailing edge. So let's go back to the global tab. I'm going to leave my geometry in this position so we can see the difference. We can see what is going to happen. And I'm going to click again the Create Surface Mesh to recreate my surface grid. All right, my surface grid has been regenerated, and as you can see, we're still in the same position. We're still looking at the blunt trailing edge, and you can see that we have a much better transition now from anisotropic cells on the blunt trailing edge to anisotropic cells on the top and bottom surfaces of my blades. Now the area ratio, we have 0 cells, so actually violate that threshold of 10, and the largest area ratio now is 3.6. So my surface grid is now ready. I'm going to click OK and let Pointwise finalize the creation of my surface grid. Last thing I can do is select all my domains and change the rendering to have a nice view of my finalized surface grid. If you like this video, be sure to click the thumbs up button and subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you so much for your attention.